Okay, this is section 8.2, exercise number 36. There's two parts to this exercise. I'm going to focus on the latter part, part B, determine whether the series converges or diverges. If it converges, state what it converges to. So to write out a couple of terms here again to just get familiar with this, this is e to the minus 1 plus e to the minus 2 plus e to the minus 3. Or if we prefer 1 over e squared plus 1 over e cubed. So we have some hope of convergence. These individual terms that we're adding are shrinking, are getting closer and closer to 0. So our divergence theorem isn't going to kick in. And in fact, writing them in this latter form, we can kind of hopefully see that this is in fact a geometric series essentially. This we could rewrite our series in this form. So it's a geometric series, and our r value is 1 over e. So certainly less than 1. And so we would have convergence. So we do converge. It's a convergent geometric series. To find the value that it converges to, we have a formula for the value of a convergent geometric series. This is our 1 over 1 minus r formula. We just have to be a little bit careful here because those formulas are based on geometric series that start with n equals 0. And when you start with n equals 0, that makes the very first term in your series the number 1. You're raising r to the 0th power. So you pick up a number 1 at the beginning. We don't have that term. So our series, we can still use the formula for the geometric series sum, but we have to compensate for the fact that we're missing that one term at the beginning. So our series is the series that starts at 0 minus the number 1. We have to kind of compensate. We're missing that initial term. So if we find the series starting with the term n equals 0, we then have to get rid of that initial term to obtain our series. But we have a formula for this one in the parentheses. This is 1 over 1 minus 1 over e. Or write this number 1 here as e minus 1 over e minus 1. And finally, with our common denominator, we have a 1 over e minus 1. So our series converges and converges to the value of 1 over e minus 1.